So, hey guys, this is Hemant, and today we are going to solve another Leetcode problem of the day. So, as you can see, this is very easy question, not so hard. There are n balls on the table, and each ball has a color black or white, and it's a binary string they have given. It's either 0 or 1. You can clearly see it, and 1 represents the black ball and 0 represents the white ball respectively. So what you have to do is in each step you can choose two adjacent balls and swap them. So return minimum number of steps so that you can group all black balls on the right side and all white balls on the left side. So clearly what we need to do is there are two balls which are black and white, and black is represented by 1 and then white is represented by 0. So what we need to do is we need to group all the white balls, which means 0 at the beginning and ones at the right. It's just simply a basic sorting of a binary string. So but the constraint is we need to do it in minimum number of steps. So that's where the question lies and makes it very interesting. So you can see one of these questions. So it's 101. So our white ball, it should come at left side. So here it also mentioned that you need to only do for two adjacent balls. You cannot do somewhere at index I is 0 and somewhere index I is at 2 or 3 or something. You can only do I and I plus 1. So that two adjacent balls. So you can choose I as 0 and another index as I plus 1, which is 1, and you can both swap them, and that will give us 0 1 1. And you can see all the white balls have been in the left and black balls are in the right, and how many swaps and not swaps, yeah, swaps or steps, how many steps you actually took in order to make this string. It took only one step, one swap. And if you go here, so initially we'll swap 0 with 1, it becomes this string, one swap, and then again we'll swap here, and white balls comes at left side, and the black ball remains at the right side. So we need at least two minimum swaps to make this all the balls, grouping them white balls to the left side and all the black balls grouping them to the right side. So you can see here it's by default grouped, so you need not to make any kind of swaps. So I've also kind of dry run myself for one of the custom input. So if you can understand this one input, right, this is the whole input and this is the input, and the answer will be 17. I'll teach you how. So if you can just understand this one input, it's very easy to solve this problem, and this is how we actually build the intuition. So what actually you need to do, you need not to swap, actually you need not to simulate this operation. All you need to see is where exactly the zeros are residing, right, in between these ones. If you can figure out where these zeros are residing and you can somehow swap them to their original left positions and find the width of that particular, you know from the right position to the place where it needs to get swapped, so that's how you get the answer. So let's just try run this. So here is the string. It has 1 0 1 1 1 0 1 1 0 0 1 1. So basic idea is that you can see here is 1 0. We'll use actually a two pointer approach in order to swap. Like I said before, you cannot swap somewhere, kind of I at 0 and somewhere at I at 2 plus 2 or 3. You can only swap adjacent, but here that is a simulation. Here we are not using any kind of simulation, we are just doing the math. So all we need to find is the certain width where it needs to get in its to its perfect place. So if you see here I'll just write the indexes as well. So yeah, no need of indexes, just follow me and then you'll understand this whole problem. And then there is one edge case, we'll discuss that one edge case and we'll implement it together. So basically, as you can see, here is our first 0, and it's need to be on the left side, and we're using 2 pointers, so I'll place I at 0 and j at I plus 1, which is 1. So whenever I see that j at the index j there contains a 0, right, I will actually completely get the width. See, I is at 0 and j is at 1. J minus 1 is 1. So we need at least one swap to get this 0 to its original left side and its grouped position. So we swap it. So we took one swap, and you can see the 0 is actually swapped. Once I swap this, now I know that 0 is residing to its original place. So if there are any zeros in the future, then it needs to be residing on I plus 1 position, right? So I'll increase my I to 1, and then j, it will continue on, it will keep on going on until it hits 0. Again you can see 0 at j index, we hit 0. Our I is at this particular 1, which is 1, and you can see from here I is at 1, so j will be at 2, 3, 4, 5. So 5 minus 1 is 4. So at least, I need to swap this, I need to swap this, I need to swap this, I need to swap this. At least I need 4 minimum swaps to get this 0 to its original position on the left group. You see, I'm only swapping in the adjacent parts. See, 0 and 1 I'll swap, and then 0 and 1 I'll swap, and 0 and 1 I'll swap, and then again I'll 0 and 1 and I'll swap, and that makes 0 to its residing position. This is a simulation, so we just need a map. We don't need to kind of swap it. Before I tried with swapping, but it's just causing, it was actually giving a lot of TLE. So it's just a basic math. So it's at least needs 4 minimum swaps to get 0 to its original place. So 0 gets to its original place, I is incremented, and j will go on further, and again it will hit 0, and we'll see how much width it's there. Again it has 6 width, and then we'll swap it, and then again I'll increment I, again we'll continue with j, again it'll hit 0, and then again we'll swap, and then this is the total minimum swaps to group all the white balls to the left and black balls to the right. And can I guess what could go wrong in this particular particular approach? What could go wrong is that I assume that always I starts at 0 index where it contains 1, not 0. You should observe here. I assume that my index I will always start at the starting index and it contains 0. It does not contains 1. Why I assume that? Because if there was a 0, then I could not use 2 pointers, saying that if, let's just say, there was here a 0, right? If I assume that I at 0 index and 1, if I use jth pointer here, right, I will just, what I'll do j is 1, so nothing to do, and then we'll move here, and then we'll just see this. Okay, there is something wrong. I'll just, whenever I hit 0, right, I should be taking this index. This is the place where 0 need to be swapped, but instead I assume that every time it starts with 1, but here the string is starting with 0, so I will take this index. So this will give me a wrong answer, taking two minimum swaps to get there. So that's the whole point. So how to resolve this solution? So if there are any leading zeros, right, we just trim down the leading zeros because they do not impact the answer. And you can ask me why they do not impact my answer. If I just give you this whole string, right, how many minimum swaps you need to get these two to the left? You can see width is 6 and 6, which is 12. So these zeros do not impact. Why does that zeros do not impact? Because this zero, right, it needs to be in this particular position, which is 1, and this one, not these both indexes. So if you can just trim down the leading zeros and go with this particular approach, you can get the answer. It's very simple. So let's just implement this. So for this, there is one more edge case. What if the string itself is as one length, so we need not to do anything but just return 0, and after this we need to kind of find, we need to trim down, actually we need to trim down leading zeros. So how we trim down the leading zeros? We just consider an index -1, we traverse throughout this string, whenever we see 0 we just continue. Okay, if s dot char at, whenever we see 0 we just, okay, we don't do anything, we just continue on further. If not, index is k, and then we found the leading zeros. So there can be one case that if all the string contains only zeros, that means we never got index where it starts with 1, we just return the 0, or else we trim down our string to index. So we are, we only did, if there was 0 1 0, we just did it as 0 1 1 1, we just trim down this particular thing. So now we need two pointers, which is I is 0, j starts with I plus 1, and then there is, we need the new length, and then also we need our answer. Initially it's 0. In the end we can just return the answer. So while j is less than, we need to traverse the whole rest string. And what do we do? What did we actually do? Whenever we see that there is a 0 residing at the jth index, we do our operation. So whenever we see it as the char at j as 0, what we do is we just take our answer, that is j minus total width, and I'll increment my I, and every time all we need to do is traverse the whole string. So this is all you need to do. Okay, sorry, there is, I forgot to mention substrings, and then okay, steps, my bad. So yeah, here you can see it runs all the test case. So this is my own custom test case, this one, just telling you how to implement this. So let's just submit and see how fast the algorithm is, and we'll discuss the space and time complexity. So you can see it beats 100% of all solutions, and it's 7 milliseconds. So what is time and space complexity? So time complexity is you're traversing throughout the string, so at only once, so often, and are we using any kind of space to compute this answer? See, you can see we are just using few variables, and even the string itself is the given string, so we are not using that as well. Yeah, we are pretty much using only constant, so constant space and then linear running time algorithm. Yeah, hope you like the video.